look at how and when do I use the continuity correction. Okay, first of all, let's say X is a binomial distribution with n and p. Okay, number of size, what is the size of the population, and then the success p. And let's say if I want to find, using binomial, probability for X is greater than 3, then in terms of normal distribution, I can approximate this. Okay, approximate this for p. X is greater than, okay, let's look at what is X is greater than 3, which area is greater than 3. Okay, let's look at 3. So that's where 3 is, and that's the low bound, which is 2.5, and that's your upper bound, which is 3.5. Now if you look at it, a sizable amount is above the curve, okay, for the bar chart, which has 3, okay, as the value, which we are looking at for the X value, X equals to 3. So a sizable amount, this, okay, is above the curve. So to fix this, we use continuity correction. Okay, we take this and sub somewhere here, so we use the continuity correction. So from here it goes to the next chart, or the next bar graph or bar chart. So now the question here is X is greater than 3 in discrete value, whereas when we approximate in normal distribution, which is a continuous variable, then we look at what are the values that's greater than 3. Okay, what are the values greater than 3? All the values that's towards the right, okay, will be greater than 3. So therefore we have to look at, that's 3, and then greater than 3. What is the first value or the upper bound that we get that's greater than 3? Since it says greater than, I definitely can't choose 3. So therefore the first value, okay, that we can approximate here is X is greater than 3.5. okay, so 3.5. and since this is normal distribution, you don't put equals to, okay, it has to be just X is greater than 3.5. okay, now let's look at the next value. Okay, I'll use a couple of examples just to make you guys understand this. Okay, next is, let's say P is probability of finding X is greater than 7. Okay, greater than 7 is over this side. Okay, so I can approximate this by using normal distribution to find the probability for X is greater than 5 for discrete. So whereas in continuous term or continuous variable, okay, where is X is greater than 7, okay, greater than 7, so that's 7. Okay, so if that is 7, this is 6.5, and that is 7.5. okay, so since its X is greater than 7, obviously I can't take 7 as my first value. So to approximate in normal distribution, using normal distribution, my first value will be X is greater than 7.5. okay, 7.5. so that's for normal distribution. So if I have a value that's greater than 7 in binomial or greater than anything, then you look at the continuity correction. Using continuity correction, I can find the answer, okay, which in this case I have 7.5. now next, finding X is, let's say, greater than or equal to 3. I'll use the same example. Okay, X is greater than equal to 3. Oops, equal to 3. Okay, when X is greater than equal to 3, this time, okay, greater than and equal to, this is 3, greater than 3, and also equal to 3. So I look at the value, everything beyond 3. But before that, what is the lower bound over here? It's 2.5, and then the upper bound is 3.5. So when I approximate, what is the lowest value that I can take? And I must include 3. But since we have the continuity correction over here as 2.5, and this is within the box or the bar chart 3, then I take 2.5 as my first value. Okay, so X is greater than n equal to 2.5. And for the next one, probability of x is greater than equal to 7. Okay, let's approximate that. Okay, when I approximate this, a normal distribution greater than 7. Okay, so I have, let's erase this. Okay, that's greater than 7. So this is 7. N equal to, greater than n equal to, so that's 7. I'm looking at everything beyond 7, and since it says greater than equal to, look at the lower bound, which is 6.5, and upper bound is 7.5. Yes, we take the value 6.5. It's my first value, greater than 6.5. Okay, now let's look at finding the probability for binomial x is less than 3, and let's approximate for that using normal distribution. Okay, so x is less than 3. Where do you find x is less than 3? So that's 3. Okay, and then the lower bound is 2.5, and the upper bound is 3.5. And since it says less than 3, definitely I can't take 3. So I'm going to look at the value towards the left of 3. So what is my first continuity correction that I have to use? Is 2.5. Okay, so that's the value using continuity correction. So 2.5 is my first value. So when I approximate the binomial x is less than 3, we have normal distribution x is less than 2.5. Okay, next let's find out the same value, x is less than 7. Okay, I'm using the same example above. Okay, so x is less than 7. So less than 7, okay, you have this side here. Okay, x is less than 7, so that's 7. So I'm looking at every value less than 7, so values towards left, so that's 6.5. Okay, so I think at this stage everybody should know, okay, if we've been following. So the probability for using normal distribution, I can approximate that to 6.5. X is less than 6.5. Okay, now what is the probability for x is less than equal to 3? I'm using the same value, x is less than equal to 3. So this one I can approximate using normal distribution. Okay, so this time x is less than and equal to, so that's the bar chart that has 3 as the binomial value. So in this case, if I use normal distribution, okay, what is my first value that I can have? Okay, this is 2.5 and this is 3.5. So continuity correction 0.5 plus minus, yes, it is value towards left. So in this case it should be 3.5. Okay, so it's x is less than equal to 3, so it should be x is less than 3.5. Okay, and sorry, this should be, since it's normal distribution, which is a continuous term, then it should be just greater than 6.5. You can't have greater than or equal to, should be just greater than 6.5. And the last one, p probability for x is less than and equals to 7. Less than and equals to 7. So less than equals to 7, that's 6.5, and that is 7.5. So we're going to include 7 and also the continuity correction. So using normal distribution, my first value will be 7.5. Okay, so x is less than 7.5. Okay, so there you go. So continuity correction is important, especially when you use continuity correction. I mean, when you approximate from binomial or any discrete variable, for example Poisson, even Poisson, that's in M2 S2. Okay, even Poisson. Okay, if I want to approximate, I can use normal distribution, and by using continuity correction I can find the answer.